told someone a secret and before you know it, it feels like everyone's in the know? Well, secrets in software aren't much different. One leak and now your secret is fair game. I'm Mariam and I'm the product manager for GitHub Secret Scanning. And today we'll dive into how, as an industry, we can secure the world's software by eliminating credential-based breaches. We'll get into the scope of the problem and why you should care. You'll probably wonder how you can efficiently detect your leaked secrets and how you could take action on those detections. And once you realize how much work remediation takes, you'll wonder how you can prevent those secret leaks in the first place. Whether you're a developer, organization, or service provider, you'll come out with clear action items on how to secure yourself and become a part of the solution. On that note, credential leaks are human error, so it's hard to place blame, and we shouldn't. But how do secrets get leaked? Well, let's take a step back and understand what a secret even is. A secret is like a password that lets a third party know that you're the one requesting access to their service. It can be an API key, an OAuth token, digital certificate, or another form of credential. And secrets can get leaked on accident. Imagine if I'm a developer and I use my credentials for a quick test to debug. I'm doing my work, developing, working fast because we love to develop fast. I commit, push my code, and I forget to take those credentials back out. Secrets can get left in Git commit history. Suppose an admin is remediating leaks and they remove the secret from the main branch, but they don't scrub the entire Git history. That's like if you have a really embarrassing text message conversation and you delete the last text to make that memory go away. But you leave the rest of your conversation there. And that doesn't really solve the problem, does it? Finally, secrets can get leaked intentionally. Maybe students or novice developers leave secrets in their code, unaware of a leak's potential impact. Okay, so we get that secrets get leaked. But if this happens once in a blue moon, do we really care? Well, secret leaks happen a lot, and they happen often. So how often do secrets leak? To set some context, GitHub has over 73 million developers and over 2.6 billion contributions per year. And at GitHub, we scan these billions of commits to detect secrets in public repositories. Every month, we detect close to 100,000 leaked tokens. And every day, we find over 100 of our own access tokens exposed in public GitHub repos. And you can expect similar numbers for other large service providers. As you can see, the problem of leaked secrets only continues to grow. It's not a problem that will go away. And there are a lot of secrets leaked in code. But here's the thing. Secrets, they don't just leak in code. Well, secrets can leak anywhere you're building software. From scanning billions of commits, we've learned that, based on leaked GitHub tokens, that secrets most commonly leak in code content, about 84%. They also leak in commit metadata, and we see about 15% of leaks there. That might seem surprising, but it's actually an understandable mistake. Assume I'm a developer setting up my IDE on my machine, and I set up a new project. I might be prompted for my Git author name and email, but I accidentally put my username and password because of muscle memory. So every time I commit now, I'm saving my credentials as commit metadata. Finally, we detect about 1% of secrets in other content types. Think pull request comments or issue descriptions. That 1% seems small in comparison, but it's still something. And a single leaked token can have devastating consequences. So we want to treat secrets leaked anywhere with urgency and scrutiny. All right, you might be wondering, do I really care if it's just one secret leak? One secret is all it takes. And the consequences of those leaks are visible throughout high-profile security breaches like SolarWinds. At a very high level, in the SolarWinds example, an exposed credential gave hackers access to the SolarWinds servers. Hackers then used that access to inject malware into customers' software updates. And this gave the hackers access to customer data. Here, we have a full supply chain breach. And the SolarWinds incident impacted an estimated 18,000 customers. Hackers with that one credential now had access to all this data that they could alter however they wanted. And we still don't really know the full extent of what information those hackers could have stolen, like government data or employee information. Could you have been one of those people? There are many, many more examples of credential leaks leading to compromised products, organizations, and even government entities. So do we just stop using third-party services? Not quite. That'd be near impossible. Do we provide more training to developers to not leak credentials? Again, leaks are just human error, even if we have the right knowledge. Now, does your organization have any leaked secrets? Well, you can find out with good and efficient secret detection. So you're working on a project and you use your GitHub token to authenticate yourself. Then you accidentally paste that secret into your code and push your code to a public repo without a second thought. So that secret's now leaked in that public repo. Now what? Since you're working on GitHub, you lucked out. For public repos, we scan all code for our GitHub patterns and our partners' patterns by default and for free. Our partners include AWS, Google, and Azure. In usually just a few seconds, either we or our partners take action. Remember, in public repos, we detect about 100 GitHub tokens a day. We revoke these tokens at once and alert our users about those revocations. We also scan private repos for GitHub Advanced Security customers. And over the past 2 years, we've seen an exponential growth in the number of repos where secret scanning is enabled. This trend correlates with the rise in security breaches over the past few years. And on average, we find about 70 secrets per customer when they first enable secret scanning on a private repo. We scan for secrets every time a user pushes code into a public repo. So when the user does push their commits, we search those commits for secrets that match our specific patterns. For public repos, we automatically scan all code for our partner patterns, including AWS and Slack, and our partners then choose to revoke and/or notify users of those leaked credentials. Scans usually take less than a second, so we can very quickly catch leaks as they occur. But what if we didn't do this? Well, at GitHub, we love to experiment. We wanted to see what would happen if we did leak a token. So we leaked an AWS access key and secret. We got an email from AWS very quickly after to let us know that our credential was leaked and the next steps to take. For our case study, we decided to ignore the guidance. We were transparent with AWS that we had committed the token intentionally. We were trying to see what would happen in the wild. We thought it'd take a few hours at minimum for anything to happen, so we went, grabbed some quick coffee, came back, and within an hour, we had 17 attempts to use the credential from random users or bots. And all those emails we received, not spam. They're notifications of actual use of our leaked credential. Of course, we monitored our credentials, and just for this one scenario, here's the impact with the downstream charges, about $81 from our little experiment that racked up in under an hour. So imagine if you leave your secret in code for an entire day, or a week, or even longer. You can easily get charged thousands of dollars a day. Again, in this case, we were transparent with AWS that we did leak the token intentionally, and our account was flagged. But for that intentionally leaked secret, this was our impact. And sure, every leaked secret is different, and we might not always see the same behavioral patterns, but this case study shows a very real example of what could happen. Okay, detections, they're great, in theory, but in reality, there can be a really big problem with detections. False positives. Well, at GitHub, and I hope everywhere else, we want to strengthen developer trust and security, and we want to equip security teams to easily tackle the most critical vulnerabilities. That means increasing signal. So every time we send an alert, a user will trust that it's important and coming from a real security threat. That means reducing noise from false positives. So let's dig deeper into this. For our GitHub Advanced Security patterns, we only surface detections for patterns with below a 10% false positive rate. I mentioned earlier that when customers first enable secret scanning on their private repos, we find about 70 historical alerts. So if we assume a 10% false positive rate, that's at least 63 or more real secrets. Not bad. But why do we care so much though? Well, many tokens with high false positive rates have unstructured patterns. Think of passwords. You can still scan for those, but secrets with less structure mean they're less identifiable, which means they're harder to accurately detect. And secrets that are harder to detect means that security teams in charge of remediating those secrets now have potentially hundreds, if not hundreds of thousands, or even millions of tokens to review. We also notify commit authors of their leaked secrets. So those developers are now also inundated with these hundreds of false positive alerts. High false positives mean low precision. This leads to alarm fatigue and low adoption or use of any tool. And all this to say that false positives are a big, annoying problem, but we're working on it. We can help the false positive problem by an industry-wide adoption of token formats that we can easily identify. For defense in depth, we can use these patterns to develop products that detect leaks with high confidence and automatically revoke the compromised credential. For our own GitHub tokens, we added a prefix, and this helps us identify that the token does belong to GitHub. We also added in a 32-bit checksum to validate the token without hitting our database. We chose our version of a checksum to strike a perfect balance between maintaining entropy levels and establishing confidence in the checksum. We work with partners too, like DigitalOcean, to mint identifiable tokens. Like GitHub, DigitalOcean has a prefix, and they have a whole lot of entropy, or randomness, to signal the finding's uniqueness. And for organizations who have specific patterns they want to scan for, GitHub Advanced Security offers our customers easy tools to define their own patterns and to dry run those patterns before they create alerts. And on our mission to reduce false positives, you can dry run your patterns before you create alerts to reduce noise. Over 50% more customers use custom patterns since we released dry runs. So good patterns mean fewer false positives. And this means that security teams have higher confidence in the alerts that we do surface, which makes it easier when you are remediating leaks. To avoid any damage, you should work with the right team members to ensure the secret is properly rotated and redistributed. You can find open source examples of how to rotate tokens across GitHub. And this is just pre-work. Once you've done that, GitHub recommends that you revoke the token to avoid any damage, like if an unauthorized user gets a hold of your token. Revoking a secret is the only way you can prevent further damage by unauthorized users. Steps before you revoke might differ in public and private repos, but no matter where the secret's been leaked, you need to make sure that that secret is revoked. So revoking the secret takes care of further damages from a malicious actor. But you should also try to prevent other developers from adopting poor development habits. That's where rewriting history can be especially impactful. And once you've made it through your main checklist, there's still more work to do. Even if your leak was in a private repository, you still need to take action. Private repos often give a false sense of security. Just because a repo is private doesn't mean that information can't leak. Also, check your API activity logs to review your level of exposure. Did you revoke the secret in time so that no one else could access it? Or do you need to take other steps in case there was a breach? Check your repo's access permissions. Make sure that nothing has changed. Make sure your contributors know how to store credentials safely, like using a secrets vault. And loop in your operations and AppSec teams for guidance on next steps. And with all this in mind, if you're using custom patterns to scan for your org's specific secrets, dig into those dry run results and hone your patterns as much as you can to reduce the time that your security team needs to take to triage these false positives. So with all that said, remediation takes a lot of work. But here's the thing, we wouldn't need to remediate if we already were just preventing leaks in the first place. Today, most detection tools search repos for leaked credentials after a contributor has pushed. This requires AppSec teams and developers to work retroactively to remediate tokens and to revoke those credentials before a hacker can exploit them. But we can be proactive about secret leaks to prevent them from the start. To review, good identifiable patterns help us detect tokens with high accuracy. If we can identify the tokens, then we can also prevent those tokens from ever getting into the codebase in the first place with push protection. In April, GitHub released a push protection feature for our GitHub Advanced Security customers using secret scanning. Now, contributors in organizations with advanced security receive notice of any identified secrets before they push their code into their org's repos. And as a push protection, secret scanning will scan high confidence tokens, those with really low false positive rates, and block a remote push if secrets are detected. This flags secrets before they're exposed. So how might that work? Well, let's take a look. Here's a file where I'm adding a GitHub token into a GitHub action file. I save the file, I commit my secret, I try to push, and I'm blocked from pushing that secret. As a contributor to my org's repo, I know where my secret was found and in which commit. I can also view resources for my org to help me out, or get a step-by-step in the GitHub docs. But sometimes that doesn't always work. We know that developers and security teams need to work together. If I'm a developer and the detected secret does happen to be a false positive, which should be rare, or a test case or something else, I have the option to unblock myself by bypassing the protection. Of course, this is for the rare circumstance, but we want to make sure that we are only blocking our developers and slowing them down for real threats. And of course, we want to prevent leaks anywhere software is built, whether that's through an IDE or the GitHub web editor. And these protections work especially well for patterns we know have low false positive rates. These are our high confidence patterns, or our highly identifiable patterns. Why don't we just add every single pattern into our push protection experience? Better safe than sorry, right? Well, a lot of customers have this question. This is like using a really big hammer to solve the problem. Imagine there's a token with a 20% false positive rate. So that means when I'm writing code, 20% of the time that I hit a block for this token type, it's going to be a false positive rate. And this leads to developer frustration, loss of trust in the product. And that means that developers are more likely to bypass the alerts, the protection. And then what's the point? Our protective step loses purpose. And you might think, okay, I get it, only patterns with low false positive rates. And we're off to a good start with over 50% of our push protection patterns being highly identifiable. This means that we scan for these pattern types and we block them with push protection. But we have many, many more patterns that we scan for in public repos. A number of those patterns have false positive rates over 10%. Compare this to our highly identifiable patterns that have false positive rates below 1%. This means that we have a lot more work to do to mint good tokens as an industry overall. The good news is that our new feature has actually encouraged some of our partners to update their patterns. So to recap, if you mint tokens that are highly identifiable, you can lower the false positives for those secrets. And lowered false positives means that we can detect secrets with more confidence. And high confidence in detections mean that we can protect those secrets from ever leaking in the first place. So with that in mind, what can you do now? As a developer, remember, security is a shared responsibility. So every person working on a project should consider security rather than leaving that to your security QA auditing team to take on that responsibility alone. Pay attention to your alerts. When you do get a notification about a detection, take action, and take action quickly. Remediate the token, revoke the token, rotate the token if needed, or reach out to someone on your security team. If you don't have a security team, reach out to us at GitHub. We're always here looking out for you. Finally, good hygiene, it goes a long way. What that means is using two-factor authentication to start, regularly updating your password so that you're not using the same password for multiple sources. I know I'm definitely guilty of this. And use a vault for your secrets. A vault is an identity-based secrets management system. It never stores a key in a persistent location. And lastly, minimally scope permissions for your secrets. For example, if you want to store a secret at the repo level, then give that secret repo level and not org level permissions. As an organization administrator, detect your secrets as a first step. Make sure you're actually scanning your code for leaked secrets. And audit. Contributors accidentally leak credentials. We know that. It's human error. Make sure you're monitoring your alerts for potential leaks found in your code or your non-code. And remediate. You might think that your org is safe if you're using a private repo. But if one of your contributors pushes a secret to a public open source project, a hacker can use that secret to get into your private repos. This has happened. And so begins the breach cycle. Remember, remediate and revoke. Finally, prevent exposure. With products like push protection, you can proactively prevent secrets from hitting your code base. This helps you stay clean, avoid messy cleanups, and reduce likelihoods of breaches due to leaked secrets. Preventative measures are the best way to protect yourself. Finally, as a service provider, your secrets, they're probably already leaked on GitHub. So what can you do? Make sure your secrets are identifiable so that they're easier to scan for and to take action on. You can work with secret scanning for free to scan for your secrets that are leaked in public repos and prevent those secrets from ever leaking with push protection. Just like that, whether you're developing code, managing organizations, or minting tokens, we can secure the world's software together. Thank you again for tuning in. If you'd like to chat some more, we're just a message away.